the lesson. Students, respond anyone. Okay. Screen is visible or not?
Yes, sir. Sir, your voice is breaking, sir.
Voice is breaking. Storage. So yesterday we discussed about the Heisenberg uncertainty principle as well as wave properties, Born's interpretation of the wave equation we discussed. Okay, so today we will discuss about Schrödinger time independent wave equation. Okay, now audio is clear. Is there any
Yes, sir.
breaking? Is it clear?
It's clear, sir.
Okay, yeah. So today we will discuss about the Schrödinger time independent wave equation. Okay, yesterday we discussed about the Born interpretation of the wave function. Okay, for explaining the motion of a particle. So that means there is a one function is required, that is the wave. Okay, so that wave properties, that means that wave should it depends on the x or y or z coordinate. Okay, as well as time also, as well as time also, it depends on the wave function size, depends on the x y z coordinates as well as time also. Okay, so one more thing is here. So for finding the probability of the electron, for finding the probability of the electron, we will use the wave, so wave function. Here psi star, psi star is the, that means psi star is the complex conjugate of the wave function. Okay, psi into psi star gives the probability density, probability density. Okay, if you want particular region, so what is the probability means, so we can take psi star into dx dy that means if you want to take only x direction, one dimension means we will take psi star into dx. If you will take three dimension, that means so we will take, instead of dx we will take dx dy dz. Okay, so if you want total probability of the system, we will integrate the that wave function, so that gives the total probability of the system. Okay, now today we will discuss about the Schrödinger time independent wave equation. Okay, for explaining the motion of the electron, so wave function is not enough, wave function is not enough, so there is a further equation also required. So like in classical mechanics, for explaining the motion of a particle, we will use Newton's laws, we will use Newton's laws. So in Newton laws, how the, that means what is the, so Newton law here, for F equal to ma, we know that force is equal to, so here mass into acceleration according to the Newton. Similarly, so according to the classical mechanics, so what role this equation will takes place, same in case of Schrödinger equation. Schrödinger equation takes place same role in the quantum mechanics, same role in the quantum mechanics. So that means a Schrödinger equation is a like a Newton's law in classical mechanics, Newton's law in classical mechanics. Okay, already we know that wave function. What is a wave function? So for explaining the motion of electron, so we will consider that wave function is psi x comma y comma z comma t. Okay, so simply we will pronounce psi. If you will take three dimension means, so we will take x y z. If you will take only one dimension means, we will take only psi x comma t, psi x comma t. Okay, so like that, so simply we will pronounce this is the psi. Okay, so from classical mechanics, differential equation of wave motion. Okay, so already for explaining the motion of a light, for explaining the motion of a light, Maxwell proposed, okay, Maxwell proposed one equation, one wave equation. So what is that wave equation means? Dou square psi by dou t square is equal to v square into dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. So this is, we will call it as del square psi. Okay, so that means here del square is the Laplacian operator. Okay, so that means this is the fundamental wave equation according to the classical mechanics. According to the classical mechanics, this equation is proposed by Maxwell. Okay, according to the Maxwell, so for finding the velocity of the wave, light wave, for finding the velocity of the light wave, he used this equation. What is that equation? Means dou square psi by dou t square equal to v square into, so dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. Okay, so if you will take only x-axis means, so this equation will be dou square psi by dou t square is equal to v square into dou square psi by dou x square. Okay, if you will take 3 dimension means, so this equation will be like this. Okay, so now here, so if you simplify this equation, instead of dou square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square, we can write del square psi. Del square psi. What is the del square means here? Del square is the Laplacian operator. Okay, Laplacian operator here, del square. This is the del square value. Okay, so now if you will take here, so this is the, we are taking here, this is equation number 1. This is equation number 1 here. Okay, now I will simplify this equation. I will simplify this equation. So how we have to simplify means, we will go like this manner. Okay, so this is the wave equation here. So dou square psi by dou x square, that means del square psi is equal to 1 by v square into, so dou square psi by dou t square. So this is the, so what is that? Maxwell wave equation. Maxwell wave equation in case of classical mechanics for explaining the velocity of the light. So Maxwell used this equation. Used this equation. Okay, so this is the classical wave equation. Here instead of del, we are substituting Laplacian operator, that equal this one. Okay, now coming to the, so this is the what is that? Second order differential equation. Second order differential equation. So this total equation is the second order differential equation. So we have to solve that equation. We have to solve that equation means, so that for that equation solution will be psi is equal psi naught into e power I omega t. Here psi naught, psi is the wave function, psi naught is the amplitude. So wave should be like this now. So wave should be, it will be up and down. So what is the maximum intensity? That is the amplitude here. Okay, so amplitude psi is equal psi naught into e power I omega t. So I is the imaginary value. Here I is the imaginary value. So I square equal to -1. I square equal to -1. Okay, now I is here, I is the imaginary value. Omega is the angular frequency of the wave. Angular frequency of the wave. T is the time here. T is the time. So that means solution of this equation. Solution of the this equation is here. So what is that? Psi equals psi naught into e power I omega t. So we can write instead of I omega t, either we can take sin omega t or cos omega t. So that means that solution will equal to psi is equal to psi naught into sin omega t, we can take psi is equal to psi naught into cos omega t, we can take. So if you will take anything, so final result will be same. Okay, so now if you will take e power I omega t means this equation will be simple. Okay, this equation, this derivation will be very simple compared to others. Okay, that's why I am taking here that solution is equal psi is equal to psi naught into e power I omega t. Okay, now coming to the, so what we are doing means, so first I am doing differentiation with respect to t, with respect to t here. So what is the parameter here? T. So with respect to the t, I am doing differentiation here. So dou psi by dou t, dou psi by dou t. So what is the differentiation of e power x? E power ax differentiation. So here I minus I omega is the a. So t is the x. E power ax. E power ax differentiation is equal to a into e power ax. That's all, na? So if you differentiate
Yes.
with yes, so e power a into e power ax, same like that only here. So I am differentiating with respect to t here. So here minus I omega is the constant. We are taking a. Okay, so that means, so if you differentiate it, so minus I omega into, so psi naught is constant as usually we will wrote psi naught. So and so minus a into, we can write, so e power minus at. minus at. So that means, so whatever e power ax is equal to a into e power ax. Same, I applied that formula here. So if you apply the first derivative, dou psi by dou t is equal to minus I omega into psi naught into e power minus I omega t. Okay, this is the first derivation. So again we will differentiate with respect to the t. Again we will differentiate with respect to the t. Okay, so here I omega is constant, psi naught is constant. We will keep both I omega as well as psi naught. If you differentiate again means, so again it will be minus I omega into e power I omega t. I omega t. Okay, so finally we will get the equation dou square psi by dou t square equal to, so here I into I into I square. I square value is minus 1. Okay, so minus into minus plus. So I square value is minus 1. Okay, omega into omega, omega square into, so this equation psi naught into e power I omega t. So psi naught into e power I omega t is equal to, so this is equal to psi we can write now. So from equation 4, so psi naught into e power I omega t equal to, we can write into psi. So I wrote here psi. That means, so finally this equation equal to dou square psi by dou t square equal to minus omega square into psi. Okay, understood this equation? Yeah. So here minus into minus plus. Okay, I into I square. I square is the imaginary value here. So I square value equal to minus 1. I square value equal to minus 1. Okay, instead of I square, I wrote here minus 1. Okay, omega into omega, omega square. So instead of this term, psi naught into e power I omega t, I wrote here psi from equation 4. Okay, so this is the, let us take equation number 5. Already we know that. So what is that, classical, according to the classical mechanics, wave equation equal to del square psi is equal to, so 1 by v square into 1 by v square into dou square psi by dou t square, dou square psi by dou t square. Instead of dou square psi by dou t square, I am substituting this value. I am substituting, so minus omega square psi. So instead of dou square psi by dou t square, I am substituting here minus omega square psi. So final equation equal to del square psi is equal to minus omega square psi by v square, by v square. Okay, now coming to the, here omega is the angular frequency, angular frequency. So there is a relation between angular frequency and linear frequency. So what is that relation means, omega is equal to 2 pi nu, omega is equal to 2 pi nu. Okay, so instead of omega I wrote here 2 pi nu. Okay, omega square is equal to, so 2 pi nu whole square. Okay, and psi as usual, and v square. So v square, so del square, finally equation will become, so del square psi is equal to minus 2 pi nu square psi by v square. Okay, so now here if you simplify it, so 4 pi square nu square, 4 pi square nu square psi by v square. Okay, now here, so we know that what is that, here frequency, so in terms of lambda. Yeah, so here frequency will be there, here velocity will be there. So there is a relation between velocity and frequency. So this is the velocity, below one is the velocity, above one is the frequency, don't confuse it. So that frequency value will be like above, up it will be, so v value will be like this. Okay, below one is the v square, v square means velocity, here nu means frequency. Okay, so there is a relation between frequency and velocity. So that's why, so I will convert this velocity in terms of frequency. I will wrote velocity in terms of frequency. So instead of v, I am substituting here nu lambda. So there is a relation between velocity and frequency, that equal to, so v is equal to nu lambda. I am substituting instead of v, so here this value. Okay, so nu square lambda square, instead of v I am substituting nu lambda. So finally it will become nu square lambda square. Here nu square get cancelled, nu square gets cancelled. So final equation equal to 4 pi square by lambda square. So minus 4 pi, del square psi is equal to minus 4 pi square by lambda square into psi. Okay, so but instead of lambda, we have to write this equation in terms of energy. We have to write this equation in terms of energy. That's why instead of lambda, we have to substitute the energy. There is a relation between lambda and energy. So we have to solve that. Okay, so for that I am taking total energy of the particle. total energy of the particle. What is the total energy of the particle? E is equal to, so potential energy plus kinetic energy. Here kinetic energy equal to half mv square. Here potential energy is V. Potential energy is V. Okay, so total energy equal to, so kinetic energy plus potential energy. Okay, we know that kinetic energy equal to half mv square. Potential energy is equal, let us take capital V. So capital V. Okay, now I am simplifying here. So above and below, just multiply with m, multiply with m in a numerator, and denominator also multiply with m. Okay, it will become m square v square, m square v square, m square v square. We know that mv means momentum. So momentum, mv is equal to momentum. Instead of mv, I am substituting momentum value. That momentum equal to p. So that means mv whole square means we can write p square here. So p square means, so p square by 2m. So here, because in numerator also, so we divide with m. So that's why it will become p square by 2m, p square by 2m plus v. Okay, this is the potential difference here. Okay, now I will bring this potential this side. So this will become E minus V. Okay, and if you multiply with the this denominator means E minus V into 2m. So if you write P is equal to under root of 2m into E minus V. So therefore P is equal to here under root of 2m into E minus V. So this is what is that momentum. Okay, according to the de Broglie wavelength. According to de Broglie wavelength, there is a relation between wavelength and momentum. So what is that relation means? Lambda is equal to h by p. Lambda is equal to h by p. Okay, instead of p, I am substituting this equation. Instead of p, I am substituting this equation. Okay, so now what we have to do means, so therefore finally equation lambda is equal to h by under root of 2m into e minus v. So this lambda value we have to substitute in equation number 6. Equation number 6. Okay, so therefore finally what we will get here, so instead of v square I am substituting. So that's why what happened, so it is in 1 by v square. So 1 by v square means, so if you write it will be, so it will be reverse. So 2m into e minus v by h square. Okay, so final equation will becomes del square psi is equal minus 4 pi square psi into 2m e minus v by h square. Okay, so this is the, if you simplify this equation. Okay, so here 4, here 2 will be there. If you multiply with, so 8. So if you bring this side, this equation, it will become plus. Okay, so final equation equal del square psi plus 8 pi square m by h square into e minus v into psi is equal 0. So this is the, what is that, Schrödinger time independent wave equation. Schrödinger time independent wave equation. So why we will call this is Schrödinger time independent wave equation means, so there is no time value here. So that means with respect to, without time we can calculate the, so what is the position of the particle here, position of the particle here. Okay, so that's why we will pronounce this is the Schrödinger time independent wave equation. Okay, if you simplify further this equation, instead of h, so h by 2 pi, instead of h by 2 pi we can write h cross. Okay, h cross. So if you write h, so instead of h by 2 pi we are writing here h cross. Okay, so if you write h cross means this equation will become 2m by h cross, 2m by h cross into e minus v into psi is equal to 0. Okay, this is equation number 9. Okay, so now this is in the presence of potential, in the presence of potential v. Okay, so that particle is there is no potential. So if there is no potential, okay, in free space, the particle is moving in a free space, there is a no free and there is no potential. So at that situation, what is the equation? Del square psi plus, so 2m by h cross square into e. So there is here potential free, that means the particle is moving in a free space, that means there is no potential. V is equal to 0 we will take, v is equal to 0. So if they ask, so what is the Schrödinger wave equation in the potential free space? So we have to write means, so del square psi plus 2m by h square, del square psi plus 2m by h square into E we can write. So that is the Schrödinger time independent wave equation. Okay, so this is about the Schrödinger time independent wave equation here. Yeah, once again, so any doubt on this? Yeah, so once again I will explain you Schrödinger time independent wave equation. Okay, here, so that means there are two types of Schrödinger wave equations are there. One is the Schrödinger time independent wave equation, another one is the Schrödinger time dependent wave equation. Okay, in our syllabus only Schrödinger time independent wave equation will be there, so no need to study the Schrödinger time dependent wave equation. So these two equations are in the presence of with respect to time. So what is the wave function, what is the motion of the particle, what is the motion of the particle? If you want to explain with respect to the time means we will use Schrödinger time dependent equation. So that means no need of time, no need of time. Okay, so that means at a particular time, so what is the the position of the wave particle, position of the wave particle. So at that case we will use Schrödinger time independent wave equation. Okay, Schrödinger time independent wave equation here. So this Schrödinger wave equation is the fundamental wave equation in quantum mechanics, in quantum mechanics. So like Newton laws in classical mechanics, like Newton laws in classical mechanics. Okay, for explaining the Schrödinger time independent wave equation, what we are taking here, so normal wave function, classical wave function. So this classical wave function is for explaining the what is that light velocity. Maxwell proposed the classical wave equation. Okay, what is the classical wave equation means? This is the classical wave equation here. So that is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square equal to 1 by v square into dou square psi by dou t square. So that means simply we can write del square psi is equal to 1 by v square into dou square psi by dou t square. This is the, so what is that classical wave equation, classical wave equation or Maxwell wave equation. Okay, so by using this wave equation we are solving the here Schrödinger time independent wave equation. Okay, for that, so what we are doing means we are solving, this is the second order differential equation. What is the solution of second order differential equation means? Psi is equal to psi naught into e power I omega t. So this is the, so you have to remember this. So this is the solution of this equation, psi equal psi naught into e power I omega t. So if we are derivating with respect to the t. Okay, if you derive with respect to the t means we will get the this equation. Okay, two times we are doing, so we are differentiating two times with respect to the t. So finally we will get the equation dou square psi by dou t square equal to minus omega square into psi. Let us take this equation number 5. Okay, so substitute this equation number 5 in equation number 2. Equation number 2. That means what is the equation number 2? So here del square psi is equal to 1 by v square into dou square psi by dou t square. Instead of dou square psi by dou t square, I am substituting here minus omega square into psi. Minus omega square into psi. Okay, so this is, so then we will get the equation del square psi is equal to minus omega square into psi. So this is the we are substituting here. So if you simplify, instead of omega, omega is the angular frequency, we know that omega equal to 2 pi nu. Okay, substitute the omega value here, we can get this equation. If you simplify it, here we can get this equation. So here del square psi is equal to minus 4 pi square into nu square psi by v square. Okay, so here, so we know that relation between the frequency and velocity. So that's why, so instead of velocity I am substituting nu lambda, nu lambda. So instead of velocity we are substituting here, so nu into nu square lambda square. Okay, so lambda square gets cancelled. So final equation will become del square psi is equal to minus 4 pi square by lambda square into psi. Okay, this instead of lambda we have to substitute in terms of energy. This value we have to substitute in terms of energy. That's why, so we have to calculate the what is the lambda value. For that, what I am taking means, so total energy E. Total energy E is equal to, so kinetic energy plus potential energy. Kinetic energy is equal to half mv square. Potential energy is equal to V. Okay, so this kinetic energy, how we can write means P square by 2m. How we are writing here means, so just multiplying with m and dividing with m. multiplying with m and dividing with m. So that means if you multiply means here m square v square, mv means p, so that means p square. Here we are dividing means here it will be 2m. Okay, therefore final equation E is equal to p square by 2m plus v. Okay, from this equation we are calculating the p value. Okay, p value. So finally p is equal to under root of 2m into E minus v. E minus v. Just already we know that what is that this value lambda is equal to h by p according to the Schrödinger wave equation. Schrödinger wavelength. Schrödinger wavelength lambda is equal to h by p. So here p value we know that. Substitute that p value here. Okay. So final equation will be this. Okay. Now instead of lambda from equation 6, so that lambda value is we are substituting here. Lambda value is we are substituting here. If you substitute the lambda value, we can get this equation. We can get this equation here. Okay, if you simplify this equation further, so we will get a del square psi plus 4 pi square m by h square. 4 pi square m by h square. Okay, into E minus v. Into E minus v. Okay. Yes, someone is unmuted. Mute yourself. Please, D2. D2. Yeah. So we are doing here. So this is the Schrödinger wave independent, time independent wave equation. Schrödinger time independent wave equation. Okay. So if you simplify this means further means we can write h cross is equal to h by 2 pi. Okay, if you substitute like that means we'll get this is the equation. Okay, so that means so at a particular time they will ask for free space, potential free space. Okay, so if potential equals 0, so we will get further equation del square psi is equal to m by h cross square into E psi is equal to 0. Okay, so this is the Schrödinger time independent wave equation. Okay, any doubt on this? So this is the very important one. Anyone have any doubt on this? Okay, so we'll go for some problem on this. Yeah, so calculate the de Broglie wavelength. So everyone note down this. So calculate the de Broglie wavelength associated with a proton moving with a velocity of 1 by 10th velocity of the light. 1 by 10th velocity of the light here. Okay, so we have to calculate the de Broglie wavelength. So lambda. So what is the given here? Velocity is given. What is the velocity means? V is equal to c by 10. V is equal to c by 10. C is the light velocity. Okay, and velocity is given here 1 by 10th of the light velocity. Okay, so that's why c by 10 we are taking here. So V is equal to c by 10. So if you substitute this value here, so c value we note that. So m value is the mass of the electron. Okay, h value is the what is that Planck's constant. So if you substitute all value, we can get the lambda value here. Lambda value. Yes, someone is unmuted. Is there any doubt? Okay, so now this is the lambda value here. Okay, how just we have to use the formula here. So lambda is equal to h by p. P is equal to, we know that, m into v. So here v is the given. So v is given. Remaining all are the constant. Remaining all are the constant. You have to remember this Planck's constant value also. So h is equal to 6.63 into 10 to the power of minus 34. M is the mass of the electron. So that is 1.67 into 10 to the power of minus 27. Okay, just we are substituting v value, velocity of the particle here. Okay, therefore we can get the, if you simplify this equation, we can get the wavelength. We can get the wavelength. So that is approximately equal to 1.32 into 10 to the power of minus 14 meters. Okay, so that is the first problem. Now coming to the second problem here. Yeah, so if kinetic energy of the neutron is 0.025 electron volts, kinetic energy is given. So kinetic energy is 0.025 electron volts. So calculate the de Broglie wavelength. Calculate the de Broglie wavelength. Okay, so already we know that formula. Calculate. So lambda is equal to h by p. H by p. So there is a relation between kinetic energy and p. Okay, so that relation is equal to p is equal to under root of 2me. Under root of 2me. E is here kinetic energy. E is here kinetic energy. So that's why, so lambda is equal to h by 2me. Okay, so here kinetic energy E value is given. E value is given, that equals 0.025 into electron volts. So here m is constant. Okay, h is constant. If you substitute all values here, we can get here. Okay, so do yourself, instead of here 0.025, so what you will do means 0.055 electron volts. The kinetic energy of the neutron is 0.55 electron volts. So calculate the de Broglie wavelength. So do yourself. Okay, so tomorrow you have to share that. Okay, you can now coming to the next problem. So here calculate the wavelength associated with an electron raised to potential of. Okay, so calculate the wavelength associated with an electron raised to potential of, so 1600 volts. 1600 volts. Okay, if you simply same, so by using here voltage is given. Voltage is given. We have to calculate the what is that wavelength. So wavelength lambda. Already formula will be same. Lambda is equal to h by p. Okay, so h by p. So already, so there is a, we are calculated different lambda values. So if you give kinetic energy, this is the formula. If you give only potential, if you give only potential means that formula will be 12.26 by root v. 12.26 by root v angstroms. In angstroms. Okay, so that means if you substitute this value 16, v is equal to 1600, so that means we can get, if you simplify it, so we can get the 12.26 by 40 angstroms. If you simplify it, so 0.3065 angstroms. So that means, so for each question, so why I am telling the problem means, so along with the question, so one problem will be compulsory, it will come. So there is a simple problem. So direct equations. Okay, so either, so if they give the Schrödinger wave equation also, so that means they will give one problem. Schrödinger wave equation also, so they will give one problem. So that problem is either belongs to the, I think maximum it will be, that problem's maximum it will be either photoelectric effect or Compton effect or Schrödinger, de Broglie wavelength. So from these three only, so these problems will come. From these three only major, these problems will come here. Okay, so tomorrow we will discuss about the particle in one dimensional box. Okay, so there are so much of time will be there now. Yeah, just I will briefly discuss. So that means this is a particle in one dimensional box. Particle in one dimensional box here. So that particle in one dimensional box is just application for Schrödinger wave equation. Application for Schrödinger wave equation. So that means by using the Schrödinger wave equation, what we will solve? What we will solve that? Okay, so that means if electron will be inside the box, inside the box is nothing but inside the atom. Electron is nothing but inside the atom. Inside the atom, so we want to calculate the energy of the electron. Energy of the electron as well as position of the electron. Position of the electron means, so by using directly wave function we cannot calculate it. Okay, just we can calculate the probability. So by using wave function we can calculate the just probability of the particle, so whether it will be present or not. Okay, so if you want to calculate the energy, and position of the particle, so we need Schrödinger wave function. Okay, so that's why for, we have to consider, there is just some consideration. Okay, so that particle is inside the potential well or so they will ask how it will be asked means, so particle in a one dimensional potential well. They otherwise, so they will ask particle in a one dimensional box. Okay, so otherwise they will ask a particle in a atom. So whatever the question, so solution will be like this only. So if particle is inside the atom only, so atom also there is some boundaries. There is a some boundaries. Okay, so here potential is infinite. So at the boundary, so this is the one boundary, this is the another boundary here. So at the boundaries potential is infinite. So here, so that means total radius of the atom or total length of the box, length of the box is equal to here L. Either radius, if you want to take radius means, like we will take a area A. Okay, so in case of atom. Okay, that means here length of the box we are taking here, so that equal to L total length. That means initial position is 0, so final point is L. So total length is L here. Okay, so at the boundary is 0. So what is the potential here? Infinite. Potential is infinite. At the boundary L, so what is the potential? Potential will be infinite. Okay, so already we know that according to the some consideration of the wave function. Wave function, there is a limitation of wave functions will be there. At the boundary, wave function is vanishes. At the boundary, wave function is vanishes. So that's why, so we are taking at the boundary psi equals 0. Psi is equal to 0. That means there is no presence of electron. At the boundary, there is no electron. Okay, similarly at this boundary also, wave function psi is equal to 0. So only inside the box, only inside the box some wave function will be present. So that means electron will be present, electron will be present. So that's why what we are taking here, so psi is equal not equal 0, psi not equal to 0. And so this is the what we are considering. One more consideration is here. So wave function v is equal, sorry, potential v is equal to 0, potential capital V equal to 0. That means this inside the box there is no potential, inside the box there is no potential. So that's why that particle will move freely, that particle will move freely inside the box, inside the box. So these are the consideration we are taking here at the boundaries. So potential equal infinity, wave function is 0. So inside the box, so potential equal 0 and wave function is not equal 0. So that's why that electron, either electron, proton, neutron, anything, so that will move inside the box very freely, very freely. Okay, this is about the particle in 1D box. We will solve so particle solution of the this particle in 1D box tomorrow. Okay, so now I will take the attendance right now. Okay, anyone have any doubts on this? Any doubts in Schrödinger wave equation? This is the very important one. Yes, voice is not clear. So can you repeat once? Yes, doubt. Is there any doubts? Yeah. So you can leave. If you don't have any doubts means you can leave.